Hello everyone and welcome back to the series of digital logic design. And in this series today we will study diminished radix complement, or which is also known as r-1 complement. For instance, we have a number n which is from base r and we wish to find its r-1 complement. Then the relationship will be r power small n minus given number minus r power minus n. Here n represents number of digits before the decimal point and m represents number of digits after the decimal point. Now we will consider the case of decimal number system whose base is 10. So 10 minus 1 will be equal to 9, and this will be known as 9's complement. For instance, we have number 99.687 and we wish to find its 9's complement. Then the relation will be r power 2 minus given number minus r power minus 3. 2 is because we have 2 digits before the decimal and 3 is because we have 3 digits after the decimal. So substituting the values, and solving, we will have 10, 9, 9, 9, and here it will be 0. So we will get 999.9. Now subtracting the given number, which is 99.687. So 9 minus 7 will be 2, 1, 3, and 0. So 0.312 is the 9's complement of 99.687. Now we will consider the case of binary whose base is equal to 2. So in that case, the diminished radix complement will be 1's complement. For instance, we have number 1101.101 and we wish to find its 1's complement. So the relation will be 2 power 4 minus given number, which is 1101.101 minus 2 power minus 3. Now solving, we will have 1 with 4 zeros dot 3 zeros minus 0.001, and this will give us 21111 and it will be 0. Now subtracting, we will have 111.1111. Now subtracting the given number, which is 1101.101, and solving, we will have 010.010. So 0010.010 will be 1's complement of the given number. Now we will consider the case of octal number system whose base is equal to 8. So here r will be equal to 8 and the complement will be known as 7's complement because r minus 1 is 7 here. Now for instance, we have number 562.13 and which is from octal number, which is an octal number, and we wish to find its 7's complement. So the relation will be r power 3 because we have 3 digits before the decimal minus given number minus r power 2, and here we have 2 digits after decimal. So it will be 8 power 3 minus given number minus 8 power minus 2. Now solving, which will be 1 with 3 zeros minus 0.01. Here we will have 8, 7, 7, 7, 7, and this will be 0. Solving this will give us 7, 7, 7. Now subtracting 562.13, we will have 4, 6, 5, 1, 2. So 215.64 is 7's complement of 562.13. Now we will consider the case of hexadecimal number system whose base is equal to 16. So 16 minus 1 is 15 and this is known as 15's complement. For instance, we have a number abc0.f1 and we wish to find its 15's complement. So the number will be, so the formula will be r power 4 minus given number minus r power minus 2. Now substituting the values, we will have 16 power 4 minus given number, which is abc0.f1 minus 16 power minus 2. So it will be 1 with 4 zeros dot 00 minus 0.01, and here we will have 16, and the rest will be 15's. Now solving, we will have f dot ff. Now subtracting the original number, which is abc0 dot f1, here we will have e0 f3 4 5. So this will be the 15's complement of the given number.
Thanks for watching the video and stay connected for more interesting videos.